Hi boys and girls, and welcome back to my channel. This is Agent Tony Says, and today we're going to talk about using the sum rule to take derivatives of given functions. Here I've written the rules that the derivative of f of x plus some g of x or minus some g of x is equal to the derivative of that function x plus or minus the derivative of g of x. Let's take a look at a couple of samples that I've prepared for you today and see exactly how this is going to work. Let's start with problem number 1. We're given 4x to the 5th plus 2x to the 4th minus 3x squared plus 6x plus 1, and we need to find its derivative. So, if you recall, using the power rule, any functions that are given in this form, we can use the power rule to find their derivatives. So we're going to use the power rule to find each of these derivatives individually, so that we're actually using the sum rule to find the final product derivative here. Let's go step by step and see what we come up with. So recall that the power rule takes the power of x and multiplies it to the coefficient of x, and then loses 1 in the power. So this will give you 5 times 4 makes 20. And then we have x to the 5 minus 1, right? So we're going to say x to the 4th power. Okay. Plus, then we have this 4 being multiplied. This is the power times the coefficient of x. This gives us 8. And then, of course, we have to subtract 1 power from x, so that we're left with 8x to the 3rd power. Okay, here we have a minus sign. Let's carry it over. And now we have this 3 times 2, and then we're losing a power here. So then 3 times 2 makes 6, and then we have our x, and it's going to be to the 1 power. Alright, now we have this derivative here. We're looking at this invisible 1 because x is to the 1 power. We're going to multiply it times that coefficient of 6, and it's going to leave 6. Now there's not going to be an x attached to this, because anything to the 0 power becomes 1. So x to the 0 power becomes 0 power, so it leaves 1. Here's another thing to think about. If you're taking the derivative of any constant, that always equals 0. So this basically just comes off. So here we have our final answer then. We have 20x to the 4th power plus 8x to the 3rd minus 6x plus 6. Very good. So we have also sample number 2. As you can see, they're not always going to look as straightforward as sample number 1. Sample number 1 is how they look like when you start, and as you get more advanced, then they'll start giving you samples that look more like this problem here, number 2. So what are we looking at? We have 5x to the 4/3 power minus 2/3 x to the 3/2 power plus x squared minus 3x plus 1. Let's go ahead and take our steps here to find the derivative of this function. So I'm going to start with taking this power, 4/3, and multiplying it to the coefficient of x. I'll show my scratch work on the side here. So what I'm doing is I have 5 times 4/3 is 20/3. Okay, so this is going to translate down here to 20/3, 20 over 3, x. Now remember, we have to deduct 1 power. Okay, so let me show that step over here. I have 4/3 minus, now we're talking thirds, so if I'm taking away 1, that would be 3 over 3. Okay, so then that leaves me 1/3. That means I have here 20x to the 1/3 power. Great. Let's move to the next step now. I have a minus sign here that I need to keep in mind, so I'm going to go ahead and write that in now. Alright, so now I'm going to take this power and multiply it to the coefficient of x. Again, I'm looking at fractions being multiplied together. So I'll show that work here on the side. Let's say that I have 2/3 being multiplied times 3/2. Well, something cool is going to happen. You could look at this as 6 over 6, which basically means 1. Alright, so in order to show that 1, I'm just going to say it's x. There's an invisible 1 in front of it. And don't forget, we're taking away a power here. Okay, so then if we're doing 3/2 minus 1, this should be a 1, not a 3. Fix that. okay? That would actually be, it would look something like this. You would say 3 halves minus 2 halves leaves 1 half. So then I have x to the 1/2 power. Great. Now I'm ready to move on to the next step. So here I have this x squared. I'm going to take that 2 and multiply it to the coefficient of x, which is 1. So it leaves me 2. Then I have x to some minus 1 power, of course, which is just going to be 2x. I don't need to show that it's to the first power. All right. So now we have one more thing here. We're looking at minus. And I wrote here that this is negative 3x to the 1 power because I want you to realize that when you do this, you get your minus 3, and then x is going to disappear. So we're just going to leave it at minus 3. And the reason for this, I'll show it here. If we have x to the 1 power, and it becomes x to the 0 power, then anything to the 0 power makes 1. So anything to the 0 power equals 1, so then I don't need to show that it's negative 3 times 1. It's just negative 3. And here, just like in our other sample, we have a constant. The derivative of a constant is 0. So this would be our final answer for the problem. We have 20 over 3, x to the 1/3 minus x to the 1/2 power plus 2x minus 3. Great. I hope you found this video useful. Please like and subscribe to my channel, and stay tuned for the next episode where I'm going to be taking the derivative using the product rule.